Okay, so we're going to be using the addition rule again. So if we wanted to, let's just write that addition rule up here. So we know the probability of A union B equals the probability of A plus the probability of B minus the intersection of the both of them. So a card is selected from a standard deck of 52 cards. So in probability, they use a lot of playing cards. So we have 52 cards because we've got 4 suits, diamonds, hearts, spades, and clubs. And they don't count the jokers. So we don't include them in the 52. So let A be the event of the card is a diamond and B be the event that the card is a jack. So here they said they're asking us how many outcomes are in the event of A. So if A is like getting a diamond, we have 13 diamonds in a set. So every set has 13 of that. So we got 13. Now, if it says what's the number of getting one of the outcomes in B, B is a jack and there's 4 jacks in a deck of cards. Yeah, so we'd say that's 4. Now, the intersection of A, if A's a diamond and B's a jack, how many jacks are diamonds? We would only have, there'd be one of them. So the number of in both of those sets is just 1. Now they're asking us for the probability. Now remember, the probability is the event outcomes over the total outcomes. So if we think about it, I'm just doing that to remind us. So A is 13 out of 52, which we can simplify to 1/4 if we want to. Now, the probability, see when we see this dash here, that is the probability that it's not A. So if we have 13 cards out of the 52 that are in A, then what's left over is 39 of the other cards out of 52, which we can simplify to be 3/4. So if 1/4 of them are diamonds, then the rest 3/4 are not diamonds. All right, so, and then what's the probability of the intersection? So we would say the probability is the number of outcomes, which we saw was 1 out of 52. All right, so then if we move on with the next bit, C, it's saying use the rule to find the probability of A union B. So we're going to keep writing these rules out. Probably by the end of the day, we're going to know how to write this without thinking of twice. So we write the rule out. This is the addition rule, okay? So use the rule to find the probability of the union. So the probability of A. Now, I'm just going to leave it in the 52 because when we add fractions, we need all the same denominator. The number that needs to be the same on the bottom. So if I keep them as 52s, so A was 13, B was 4 out of 52, and then this was 1 out of 52. So that makes it easier because if I go 13 plus 4, that's 17 minus 1. So I end up with 16 over 52. And then when you can simplify that, so 4 goes into both of those numbers, 16 4 times and 52 13 times. All right, so that was C. Now, okay, D, find the probability that the card is a jack or a diamond. So what's that means is find the probability, or means union. So the probability that it was a jack was B, the event, and diamond was also. So we want A union B. Yeah? So if they said find the probability that the card is a jack or the diamond, we've already just done all of that working out. So we could say, because a jack was was a jack B and the diamond was there. So we've already shown that, yeah? And we could just say it's 4 out of 13. We'll just repeat that again because it's or and that. Okay, so I'm going to pause the video for a minute and you guys are going to give this one a go. Do it in your pencil. I'll give you a few minutes and then we'll go over the answer. All right, just looking back here, I read this wrong. It says the probability that it's a jack, which was, I believe the probability of B was a jack, and not a diamond. So that's in union with not A. So we would still say that it would be, if we were working it out, it'd be the probability of B plus the probability of A minus the intersection. Oh my God, I'm going to run out of... minus the... I'll have to do it on the next line. Minus the intersection of B intersecting with not A. Okay, so we have got that. We had all those stats there listed. So the probability of B was 4 out of 52. The probability of not being A was 39 out of 52. And what's the probability that it is a jack but not a diamond? How many have we got? How many jacks that are not diamonds? We've got how many jacks in a set of cards that are not diamonds? That would be 3. So we'll say like that. So the probability it's a jack and not a diamond. So there we go. So we end up with 40 over 52, which can go to 10 out of 13. All right, so we just had to fix that one up. So if we go through the next questions, it was very similar. So we could go to answer through all them. So the number of A was a club. So there was 13 choices. B was a queen. So there's 4 queens. And the number of double up intersection for both A and B, there's 1 queen that's a club. So we went through all the same. It's pretty much similar. So you would have found it's the same probability, but here again, we've got the probability that it is going to be a club. So the club is a queen, but not a club. So we do that. Let's write. We can hopefully got a bit more room here. So it's a probability that it's not a club minus the intersection of those both. Okay, so we saw that the probability of it being a queen would be 4 out of 52. The probability of it not being a club would be 39 out of 52. And how many queens are not clubs? 3 out of 52. So we end up with the same, 40 out of 52 and 10 out of 13.